Using the KY026 flame sensor with ESP8266 node MCU. The main objective of this tutorial is to design and implement a flame detection system based on the KY026 sensor, controlled by the ESP8266 microcontroller, and equipped with an LCD I2C screen for real-time data visualization. When a heat source approaches the KY026 flame sensor, a reduction in the sensor's output value is observed. When a heat source or flame gets closer to the KY026 flame sensor, the sensor receives more infrared light. The photodiode inside the sensor reacts to this light by allowing more current to pass through. As a result, the output voltage decreases, and the reading becomes smaller. ESP8266 assembly with I2C LCD display and KY026 flame sensor. The ESP8266 acts as the main microcontroller that reads data from the KY026 flame sensor and controls the LCD display. The I2C LCD display is a character LCD module that can display text, symbols, and messages. Connect the GND pin of the display to the GND pin of the ESP8266 board. Connect the VCC pin of the display to the VIN pin of the ESP8266 board. Connect the SCL pin of the display to the D1, GPIO5 pin of the ESP8266 board. Connect the SDA pin of the display to the D2, GPIO4 pin of the ESP8266 board. The KY026 flame sensor detects infrared radiation emitted by flames. Connect the VCC plus pin of the flame sensor to 3V pin of the ESP8266 board. Connect the GND pin of the flame sensor to the GND pin of the ESP8266 board. Connect DO pin of the flame sensor to A0 pin of the ESP8266 board. Here's a MicroPython program that reads the DO output of the KY026 and show value on an I2C LCD screen. You can learn more about robotics on my website, robotique.site.